Welcome back. In this video, we're going to talk about collision detection and how we can detect when the circle collides with the axe. Let's get started. Now you may have noticed that the circle reaches the right edge of the window and actually dips off of it a little bit, and that's because we're using the circle's center as its position. So checking to see if it's greater than or equal to the right edge of the circle only prevents the circle's center from going past it. This is also why we see the axe bounce off the top of the canvas but dip down below the lower edge, because we're using the top left corner of the axe for its position. Now imagine we have a square surrounding our circle. The circle's center has coordinates circle x and circle y. So we can think of the edges of the circle as being the center plus or minus the radius, which we can call r. Now let's say our circle's moving to the right, and we want to detect whether or not it overlaps with 300 in the x. If the circle's position is 200 and its radius is 25, then its right edge is circle x plus r, which is 225. Advance to the right by 25 units, and circle x plus r is now 250. Another 25, and it's at 275. Another 25, and the right edge of the circle has hit the 300 mark. In other words, we can say that we have a collision when circle x plus the radius is greater than or equal to 300. But what if we have a vertical column with a left edge at 300 and a right edge at 350? And we want to know if our circle is colliding with that column. Well, if the circle goes all the way past the right edge of the column, we're no longer colliding. And we need to check to make sure that hasn't happened. Well, if we take our circle's left edge to be the circle x coordinate minus the radius, circle x minus r, then we can check to see if this edge is colliding with the column. Move the circle to the left a bit, and now we have a collision. So we can see that we're colliding if the left edge, circle x minus r, is less than or equal to 350, which is the column's right edge. So both of these conditions must be true to have a collision. Now the horizontal lines here represent the movement of the circle. The top horizontal line has a y-coordinate of 200. Now, if we want to detect whether or not the axe has collided with this horizontal line, we can check the axe's lower edge. The axe's lower edge is the axe y-coordinate plus h, where h is the height of the axe. Once the axe reaches the y equals 200 line, then axe y plus h is greater than or equal to 200. But if the axe has passed all the way through past the lower line, which is at 250, then we're no longer colliding with this movement track. Move the axe upward a bit and we're colliding again. This is when axe y is less than or equal to 250. So we have an AND situation here as well. So we can represent the coordinates of the left, right, upper and lower edges of our circle by using the circle's center coordinates plus or minus the circle radius. Look at the first line here, which declares the variable L circle x. This is the x-coordinate of the circle's left edge, and it's equal to the circle's x-coordinate minus the circle radius. The next variable, r circle x, is the x-coordinate of the circle's right edge, and it's equal to the circle's x-coordinate plus the circle radius. Next we have u circle y, which is the y-coordinate of the circle's upper edge, which is the circle's y-coordinate minus the radius. And finally, we have b circle y, which is the y-coordinate of the circle's bottom edge, which is the circle's y-coordinate plus the circle radius. We can represent the axe edges similarly. So your next challenge is to create a variable for the circle radius and initialize it to 25. Call it circle underscore radius. Also, create a variable for the axe length. Call it axe underscore length and initialize it to 50. Then use these variables in draw circle and draw rectangle instead of hard coding the values in these function calls. Pause the video and do this now. Okay, we're back here in our program. I'm going to go up to circle coordinates, and just under circle y, I'm going to create an int called circle underscore radius. And I'm going to initialize it to 25. Now just under axe coordinates, I'm going to create a variable called axe underscore length, and initialize this to 50. Now we can scroll down to our calls to draw circle and draw rectangle. And for the draw circle radius, instead of 25, I'm going to enter circle underscore radius. And for draw rectangle, instead of a width and height hard-coded at 50, I'm going to use ax underscore length for both of these arguments. Okay, excellent. Now together, we're going to add a few more variables to our circle coordinates and ax coordinates sections. Just below our circle coordinates section, let's add another comment and say circle edges. Now we're going to make an int called L underscore circle underscore x. This is going to be the x coordinate of the circle's left edge. We'll initialize it to circle x minus circle radius. Next, let's make an int called r circle x. This is the x coordinate of the right edge of the circle, and it's going to be equal to circle x plus circle radius. Next, we'll make an int called u circle y, and this will be the y coordinate of the circle's upper edge. So it's going to be circle y minus circle radius. And finally, we'll declare b circle y, which is the y coordinate of the circle's bottom edge. So it's going to be circle y plus circle radius. So now we have 4 variables corresponding to the 4 edges of the circle. Now let's go just below ax coordinates and make a new comment and say ax edges. Now we'll make a new variable called L_x, which is the x coordinate of the ax's left edge, and that's just going to be ax underscore x. Remember, the ax's position is the upper left corner of the rectangle. We'll make another variable called r_x, and this will be ax plus ax length. And that's the x coordinate of the right edge of the ax. Next, we'll make uxy. This is the y coordinate of the upper edge of the ax, and that's just xy. And finally, we'll make bxy, and this is the y coordinate of the bottom edge of the ax, and it's xy plus ax length. So now we have 4 variables representing the outer edges of the ax. Great job! Now before we wrap this up, let's scroll down here to where we check to see when xy is greater than 450. Instead of using 450, we should use height because height gives us the dimensions of the window. Likewise, when we check to see if circle is less than 350, we should really be checking to see if circle is less than width, because width is the width of the window. Now if we change the dimensions of the window, we don't have to go down here in our code and change the numbers. This is the beauty of using variables rather than hard coding values. Okay, so in summary, we learned about how collision detection works. We learned that we had to use the dimensions of the circle, namely its radius, in order to detect if the circle's outer edges collide with a particular line. We also learned that we could use the dimensions of the ax, in particular the ax's length, to detect whether or not the ax collides with a particular line. And finally, we created variables for the collision boxes of our circle and our ax, consisting of the x coordinates of the left and right edges and the y coordinates of the upper and lower edges, respectively. Now we have data that can help us in our collision detection. See you in the next video.